In this video, we'll talk about necessary and sufficient condition for convergence in probability. So remember that we say a random sequence xn converges to a random variable x in probability if we say that limit of probability that the distance between xn minus x being greater than epsilon when n goes to infinity becomes 0. Now, so in many practical situations, x of n may converge in probability, but we may not be able to find, or we may not know the converging point. In that case, we want to verify if this random sequence first converges or not. This theorem says that this random sequence converges to a random variable if this limit is 0. In other words, that if, let's say, this is time and this is like n and this is like m, if you could guarantee that probability that these two random variables that are further away from each other bigger than epsilon, and if the limit of this is equal to 0 for all positive epsilon, if this is satisfied for all epsilon non-negative, then this is sufficient to conclude that there exists a random variable x such that x of n converges to x in probability. And then this definition. Moreover, if there exists x such that x of n converges to x, we have this. So in other words, this is a Cauchy version of this convergence. So the proof is not very important, but you can use it. So quite often it is much easier to verify that, and if this is verified, then quickly can say that there exists, even though you may not be able to find it. But of course, the theorem also finds x for you.